Well, hello again everybody, and today on the bench we've got this HP5335A Universal counter. Now this counter was actually, well, it was a piece of free test gear that I scored, didn't pay a penny for it. Bit of a story, I was working at my friend's garage helping him put an engine in his American truck, and the guy who ran the garage said that he had some electronic items, because for some reason, this isn't somebody I knew, but he'd come to hear that I was interested in electronic stuff, and he said, oh, come upstairs, and I thought, oh, you know. Anyway, he did take me upstairs, and there was this test gear. Well, there was this piece of test gear. This is a Hewlett-Packard Universal counter. And he also let me have, and I can't just show you at the moment, but it's just looking over, it's a Ballantine programmable time and amplitude test set, a model 6125C. Now, I wasn't exactly sure what an amplitude test set was, but I've been talking to Simon Spears on Twitter, and he says it's the sort of thing that you use to calibrate oscilloscopes. Well, the amplitude test set works fine. But I plugged this in, and yeah, it doesn't work. It was probably the most dirtiest piece of test gear that I've ever seen. It was absolutely covered in grime and dirt, and kind of the garage where this has been stored. They do a lot of grinding and welding, so it was actually caked in muck. So I had to take it out of the garage, and I kind of vacuumed it with a soft, brushed it all out with a soft bristle brush, and then vacuumed it, and then I've got an air line out, and I blew it with compressed air, and I think I've blown most of the abrasive and metal dust out of it, and well, it's come up really quite nice, but it does have a problem. It doesn't work. I don't know any more than that. So we need to investigate, don't we? So without any further ado from me, let's plug it in and have a go. So here's a lead. I have checked that the voltages are correct. Okay, got a red light on the front. Red light, power, standby. So let's switch it on. Well, the fan's kicked up, so that's a useful sign. The power light has gone off, but we haven't got any display. There's no characters lit. So I guess what we should do first is, I think it's EV Bog, isn't it, Dave Jones? It's good advice. Thou shalt check power supplies. So let's go ahead and do that. You know what? I don't really like putting my hands in test gear anymore. I don't know if it's just me, but I seem to be getting a bit shaky, or maybe it's just that I don't get enough practice at test gear as I used to. So I think we'll just turn it off a second. Okay, so we need to find, let's have a look. Okay, so we've got a board at the back here. That's got a big transformer on it. It's got some fairly meaty capacitors. It's got some sprags there, normally bad news, aren't there? I don't know what that is. It looks like it's got some form of oh, is it HP GPIB control bus maybe? Looks a bit like it, don't know. Looks a bit like the old Centronics connector on the back. I can never remember what they call that. Ooh, right, so yeah, it looks like this board here is a power supply board. It's got a big jumper to the main board, and it's got some edge connectors feeding various other things. Got some fuses. What do they say on them? +5, I think that says +5, 5 amp. +5, 2 amps, -15, and oh, can't see that. Let me put my big head in. -15, 1.5 amp, and +15, 1.5 amp. So let's check the supplies. So is that a ground? Yeah, that looks like a ground. Let's see if we can get a metering shot for you. Are we on DC volts? Yes. Can you see that? I think you can. Let's switch on. Let's just go off the fuses first. So let's try the +5. 12 volts. That doesn't look very healthy. minus 5 is minus 12. Let's have a look at the 15 volt supply, minus 15 volt supply there. That's minus 27, isn't it? Let's look at the plus 15 volt supply. 27. Let's just check all the other sides of the fuses because I only checked one side there. So 27, 27, minus 27, minus 27, minus 12, minus 12, plus 12, plus 12. So our fuses are good. Okay, so I did print off some diagrams for this, and switch that off, and everything came out apart from the actual power supply section, which is just like a really bad scanned copy, but you can roughly see what's going on. Can you see that on your screen? Let me see if I can bring it in so you can see the diagram a little bit. Can I zoom you in? Let's have a quick look. So we've got a big transformer here, which is that one at the back. We've got a transformer, we've got some bridge rectifiers, which I can see, oh, what is it, what Simon calls them? Rectum fryers, that's it. Got some bridge rectum fryers down there, haven't we? So yeah, they're down there somewhere. And this is interesting. It looks like all the supplies to the output rails, they go through this main relay. And I'm kind of wondering why they've done it like that. Why they've got this interposing relay there. Because if you wanted to switch all the supplies on and off, well, it seems like you might switch the main transformer on and off. I guess it's so they could maybe have the standby function. It just seems like a little bit of an odd arrangement. So there's a relay there. Can you see that? There's a little plastic relay down there. Let me bring you in. Okay, can you see that? There's a relay down there. Hopefully you can. So it looks like this this relay takes the unregulated DC, and certainly, like I say, this is a bit where it's all pretty illegible. I think that is, I think that's a plus 15 volt supply, and I think that's minus 15. So it looks like the plus 15 and the minus 15 are those 3-pin legged jobbies, 3-pin, you know, package regulators. So I'm guessing that if they're a 15 volt supply, it wouldn't be completely out of order to get a plus and minus 27 volt supply into the input side of these things, would it? Yeah, so looking at it, I was looking at the voltages adjacent to the fuses, which is actually before they get regulated. So that's probably why we were seeing the higher voltages. So let's switch it back on, and there is actually some labels on the board, so let's have a look at those voltage labels. Can you see what's going on there? Okay, let me just have a look. So we've got before I power up, let's just have a look. We've got a minus 15 there, got a plus 5, got a plus 15 down there. And I think there's a minus 5 somewhere, but I can't just see that. There's one over there, a transistor down there that's got minus 5.2 written against it. Let's see. Let's power it up again and let's see what voltages we can measure again. So let's check the plus 5 volt rail first. Right. Okay. So that's 0.2 volts. So that's not looking very healthy, is it? Let's check the minus 15 volt rail. That's minus 3, so that's not very good. See if we can check the plus 15 volt rail. And we have got 15.04 volts. And I did say I thought there was a minus 5.2 volt rail. I don't know if that's down here. Let's have a look at that. That's got plus 0.6 volts on it, so that's not very healthy. There's a plus 15 volt regulator, which was it 15 volt we had, or minus 15? I don't know. We had one of those supplies anyway. Can't remember which way around it was. Got memory like a sieve. But interestingly, the plus 5 volt supply and the minus 5 volt supplies, they're derived from some op-amp arrangement, and those I'm going to say the op-amps, it's an op-amp symbol, I'm not sure what they are. They look like op-amps, and I can see that those op-amps have got they've got plus 15 volt supplies and minus 15 volt supplies, so they're obviously designed to run off a split rail. And as we just proved, we've only got one of the 15 volt supplies, whichever way around it is. So I'm guessing that if we're missing one of the op-amp rails, we're not going to get a 5 volt output either, and we're also not going to get minus 5 volts out of it. So I think we've got to find out, we've got to fix these two supply rails, or basically fix the one that's died. So using a couple of external pass transistors to actually regulate the plus 5 and the minus 5, and also looking at it, there's, well, again, I'm not exactly sure what they are. I don't know if that's 0.15 ohms, so it looks as though it's got some you know, some current shunts on it, so maybe it's doing something you know, it's doing something cunning. It's if you get a short circuit on the 5 volt rails, it looks as though it's turning the pass transistor off. Something a bit like that anyway. So it looks like we're going to have to take a closer look at this minus 15 volt rail, and it's hard to read it, but it looks like I think it says U7. I think it's U7. Like I say, this is what I downloaded from the HP website, and the manual is perfectly scanned apart from the power supply section, which is kind of almost illegible. You can see the blocks and you can see that there's writing there, but yeah, you can't really make it out. You can just make out the odd letter or word, but it's yeah, it's pretty illegible. Now when you look at most PCBs, they've got an ident layer, haven't they, where you can actually see what all the components are marked, and it looks like it does have some idents marked on it, but they've actually you know, they've actually marked it on the copper clad rather than using a separate labelling layer. I wonder why they've done that. Maybe, I don't know, I was going to say maybe it's price, but this piece of equipment probably certainly wasn't built down to a price. It would have, I'm guessing everything HP was quite expensive back in the day. So we've got some transistors down here, and oh, my eyesight is shocking. There's a tip 121, no, it's a tip 106. So that's probably, yeah, that's got minus 5 volts written next to it. That's that one. I'll tell you what, I was going to turn the power off before I put my hand on something I shouldn't. So we've got a transistor, we've got one there, we've got a pass transistor there which has got minus 5.2 written on it. We've got another transistor here, and I can't make out the writing on that, unfortunately, but it's got the number 6 written on it, and it's also got a little potentiometer next to it. Just lift the magnifier out of the way. It's got a little potentiometer next to it, so I think the plus 5 volt rail has a, I think the plus 15 volt rail has got a variable resistor on it, potentiometer for maybe fine adjustment. Yes, it is. So I'm going to take a guess that yeah, that one is the plus 15 volt rail. So I think there's a dead spider or something down there, little bugger. Let's see if we can get rid of him. I can just see that when stabbing this probe in. I'm afraid you can't. All you can see is my hands. I can just see if I try and stab this probe onto here, it's a long probe, and I run the risk of shorting something out. And my meter's turned off. Great. So it looks like the third pin is the pin 3 is the output on it, and that's at that's 0.3 volts out. Now I think we've all played with voltage regulators, haven't we? And there's going to be a couple of favourites. Either the voltage regulator is just going to open circuit, and then you've got to ask yourself, why is it going to open circuit? And of course, what usually tends to happen on equipment of this age is you'll have some tantalum caps, and there's a lot of caps on here, and I don't know if they're tantalum or not. I think they might be. So you've always got the favourite of there's a capacitor somewhere that's gone short circuit, and that's the reason why we've got no minus 15 volt rail. So I think we need to investigate that a little bit further, don't we? So let's just put the meter on ohms and let's go between the 3 pins on this regulator. See what we get. So pin 1. Yeah, pin 1 certainly is linked to the ground plane. It certainly appears to be. Let's have a look at pin 2. Pin 2 is at 2.4 meg. Well, it doesn't really mean anything to me that, but it's not a short circuit. And pin 3 is showing 1 ohm, which to me appears suspicious to say the least. So I think we've either got a short in the regulator to ground, which probably would have resulted, yeah, it's a bit strange that. I think this regulator, this 5 volt, this minus 15 volt regulator, I'm guessing it must have gone open circuit, because if it had gone short circuit, it would have blown the this minus 27 volt fuse that we checked earlier, and it hasn't blown it. So that regulator, that 15 volt regulator, minus 15 volt regulator, must have gone open circuit. So the question is why? Is it because its output has gone short circuit? It's quite likely, isn't it? Okay, well it's another day later and it's back on the 5335A Universal counter. Now I was playing around with this minus 5 volt regulator and I managed to track one down. I had a look on Farnell and RS and it was a bit annoying. The only minus 15 volt regulators I could find, they wanted me to buy a tube of 48, which I was a bit reluctant to do. So I had another go with their search engine, if you like, and eventually I did manage to find another listing, but it certainly didn't come up immediately. That won't fit. So what I'm going to do is, although it hasn't arrived yet, I haven't got another minus 15 volt regulator. But I'm pretty sure there's a short circuit between the output of the regulator and the ground, and it's likely to be something like a tantalum capacitor. So what I'm planning on doing is I'm just going to desolder the 15 volt regulator. I keep getting my names mixed up, don't I? I must be going a bit mad. I'm going to disconnect. I'm going to unsolder the minus 15 volt regulator. And I'm going to just try bodging in a bench power supply to generate the minus 15 volt rail. And my kind of crude plan is kind of see what starts smoking, or maybe if I can run enough current through it I can take some measurements to try and pin down whatever's pulling the rail down. So that's the plan. It's a bit awkward to get to these transistors. Always seems to be something just a little bit in the way. So there's a screw removed. I think there's some insulation behind that. There's a little piece of ceramic or plastic. Okay, so it's got a little insulator. I don't know if that's an insulator or just a metal packer. It does look metallic. Yeah, I'm not sure. And it must be an insulator because it's got a top hat around the regulator IC. Okay, so let's plug the solder sucker in. Let's get that out and we'll see. We'll take it from there. Okay, so that's the regulator, the 3 pins of the regulator that we've got to remove there. So let's just whip that out. Warning: 120 volt these holes. So try not to put my tongue on them. I don't even remember. I had a little bit of trouble, didn't I, with my solder sucking last time. It didn't go as well as I hoped. And I think basically what I learned was that the regulation, the temperature on the end of this tip isn't actually anywhere near as hot as kind of the temperature setting led me to believe. I think I was actually running it a little bit cold. Annoyingly, I think my tip is too small. Increase the tip size. Damn. I wonder if my solder sucking will go any better than it normally goes. Fingers crossed, eh? That doesn't sound as though it's sucking very well. I think I'm going to buy another solder sucker. I don't think it is me, I just think this paste one is rubbish. I think I'm going to have to invest in one of those big Hacko ones or something. I just don't seem to do very well with these paste jobbies. Which is a shame, because I do like, you know, I am a bit of a paste fanboy. Well, saying that, maybe I'm not. I actually quite like the Metcal equipment, but what kind of puts me off is I've only just learnt what hand pieces and bits that I need to order for this one, and the pain of having to you know, do all that. That sounds a bit better. The pain of having to learn everything again, you know, what the Metcal equivalents are, yeah, that doesn't really excite me. So yeah, I think I'm almost ready to give up on this paste desoldering station. It's just never been very good, to be honest. That's all I can really say about it. I've never found it works particularly well. Kind of record that, isn't it? Anybody else take 20 minutes to unsolder one 3-pin regulator? Must be some kind of record, eh? I can actually see the number on it now, which is 18260214. Okay, so we've got our power supply set up there, and I'm just trying to generate this minus 15 volt rail, and you can see that the power supply is flashing, and that's because it's folded back in its current limiting. So I'm just going to have a look at what the voltage is across the minus 15 volt rail. And I'm getting a voltage of about minus 0.2 volts. So it looks like we've got a pretty hard short circuit there. So what I'm going to do is I'm basically just going to turn up the current limit, and well, to put it bluntly, I'm going to see what smokes. Might even try getting the thermal imaging camera out and seeing if we can see anything warming up. So let's turn the current limit up a little bit more. I'd have thought 500 milliamps should be enough to show something, shouldn't it? Well, I think we need a bit more power. Should we try increasing it to an amp? Oh, something's getting hot. Right, right, found you, got you. Ow, 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 turn off. Ow. Oh, burnt my finger. Okay, so this little bugger is red hot. So let's see if we can get rid of you. Bit crude. Okay, so we've cut that tantalum capacitor off, and the power supply is now not current limited, and we're at 10 volts. So I wonder if we dare turn that up a bit to generate our minus 15 volt rail. I think we will do. That's good enough. Now, I don't know if it's a good idea or not, but shall we try and power the thing up? In theory, and it is only in theory, maybe the other rails will come up. Right, what does everybody reckon? Shall we try powering it up using this temporary supply to generate our minus 15 volt rail? It's worth a try, isn't it? It might work, might not. Hopefully it won't go into some strange SCR latch up mode, which means it probably will. Well, we don't seem to be any better off there, do we? So let's have a poke around, see what we've got on our supplies. So there's our minus 15 volt rail. There's our plus 15 volt rail. Have we got a 5 volt rail? No, we don't have a 5 volt rail. So the next question is, why haven't we got a 5 volt rail? Could be the same again, of course. We've got one bad tant there, God knows how many other bad tants we've got. You know, I was just hoping we were going to get lucky there, but obviously not. So I've started looking at the plus 5 volt rail because when I ran the machine up using the minus 15 volt power supply, I thought that the minus 5 volt, sorry, I thought that the plus 5 volt and the minus 5 volt rails, I thought they were probably going to come up because this is a regulator that drives them. And for the 5 volt rail, we've got an NPN pass transistor here, and we've got, I don't know what you exactly call that, an op-amp comparator, whatever. Basically, it's comparing the output voltage from the from this pass transistor here, and it's trying to put a 5 volt supply out of it, and there's a low ohm resistor here with a transistor across it, and what that's doing is if you get a short circuit, you get a voltage dropped across R7 which switches on that transistor, which diverts base current away from the pass transistor, which turns the output off. But lo and behold, this transistor, this pass transistor, is also dead. So we can just confirm that because I've taken it out of circuit. And I think if we test it, it does make rather a little sad little whine. So let's just have a go at that. No component detected. How sad. Well, it looks like what this is. I've managed to cross-reference it again, getting some help off the EV blog, because they have this manufacturer's code on it. This well, I think it's actually more of a HP code. This 4-611, and when I typed that in, nothing really came up for it, but I managed to find a cross-reference of Hewlett-Packard part numbers, and yeah, that looks like it's a 2N6055, which is a NPN power Darlington transistor, 8 amp, 60 volts. So we need to get one of them. I haven't got one, but we need to get one. But I suspect what we'll find is if we just put that in and run the unit up, I suspect we're going to find a similar problem to before. We're going to end up probably frying this transistor, because I suspect on the 5 volt rail we've probably got something pulling it down as well, and I'm suspecting again, you know, some bad tantalum caps, because you know, these things like buses, you kind of wait around for ages and then well, 2 or 3 turn up at the same time, but tantalums are even worse than that. If you get one bad, chances are you get lots bad, and you know, the correct thing to do is once you find one bad, you just replace everything on the board, and I'm hesitant to do that because I'm basically very lazy. So I don't know. What I might just do now is I might just seeing as I haven't got this pass transistor, I might just connect 5 volts to the emitter, the output, what would have been the output from the pass transistor, and just turn the voltage up slowly. And what we'll do is maybe just monitor the voltage across R7, which is I think that says 0.15 ohms. So if I monitor the voltage across that resistor there, that's going to give me an idea what current it's drawing. And I say monitor the voltage, we'll just stick our finger on it and see if it burns me. That's how we're going to do that. So let's put 5 volts on here. Let's connect 5 volts to the emitter and see if the 5 volt rail comes up. I'm not expecting it to, but who knows. I'm not sure if this will come out on the camera, but I've just, it's upside down, isn't it? Yeah, okay, try again. So I've just connected 5 volts to the output, the emitter of this pass transistor, and just to see if you know, putting a 5 volt rail on it would do anything. And what I was expecting it to do was to get some more tantalum capacitors red hot, and I could probably see them with my thermal camera, and then I could just cut the buggers out and carry on. Anyway, I've connected up my 5 volt rail from my external power supply, and we have some life. So here we go. There we go. Fail 41. So looks like we're getting a bit closer. I mean, the fact that we're getting a fail message means that well, I think that's a fairly major step forward. That I don't know what fail 41 means, but it might be fail 4.1. But what it does mean is the microprocessor's definitely running and the multiplex display's running. So we're certainly a little bit further forward than we were. So yeah, I'm going to take that as a good sign. Well done, me. And it also just looks like we have some basic functionality now, so that looks like a good sign as well. So you never know if Lady Luck shines on me as opposed to doing something else on me. Maybe when we get this new pass transistor for the 5V rail, which I've just ordered from DigiKey in America, so maybe if we get a new pass transistor and the minus 15V regulator arrives tomorrow from RS Components, maybe we'll have some look at getting this running. Anyway, both fingers crossed there.